Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good day. My name is Muhammad AMIRUL bin AFRIDAL, FB19080. So today, my group will present about control system project, which title is antenna control. So I will start first with introduction. So the introduction is one of the fastest growing fields of science and technology is satellite communication. It is beneficial to share information throughout the globe. Signal transmission and reception are both aided by the antenna. The quality of the received signal, amplitude or strength is determined by the satellite's relative positions, antenna position and antenna specifications. The antenna parameters are fixed after design. This signal quality is determined by the antenna position when the transmit signal power is fixed. It can be fixed in the form of coordinates. The operator or label adjusts these coordinates manually. When the antennas are used on mobile vehicles, they are also being used in many others applications such as measuring system, tracking or positioning system, and also systems that are subjected to natural disturbance and in big antenna system. But they have a small weakness, which is the manual adjustments. The manual adjustments are limited, and the antenna should be oriented within 1/10 of its beam width to reduce pointing error. The antenna coordinates are automatically aligned, allowing the best quality and strongest signals to be received. And then about the electronic and mechanical components, as well as the control algorithm, make up the antenna control system. The system primary needs include the minimal feasible pointing inaccuracy, fast speed, and low power system, among others. And the antenna also are divided into categories, which is tracking and positioning. A tracking system follows a moving item indefinitely without halting. It follows a moving signal source or item, such as communication satellite, spacecraft, or other moving object. By continuous tracking, it can choose the best signal strength for a specific step. The receiving antenna must track the target satellite precisely in order to receive signals from it efficiently. It is done by the receiving antenna system in accordance with a specified search pattern. And from the diagram, we can see the electrical circuit of the DC motor for the antenna. So a position control system translates the position input command into a response in the form of a position output. Antennas and robot's arm are both examples of where position control systems are used. A technique for controlling the azimuth of antenna, and one system that makes use of position control system is shown in figure 1. So we can see from the figure 1, the goal of the system is for the antenna's azimuth angle output to match the potentiometer's input angle. That's all from me. I will pass to the next presenter. Thank you.
Hi, Assalamualaikum. My name is FAUZIN bin AZMI, and my metric number is FB14103. I will continue with the presentation with 2.0, which is methodology. So, a position control system convert a position input command to a position output response. Then, position control system find widespread application in antennas and robot arm. An antenna's azimuth is one of the example of system that use position control system. So the purpose of the system is to have the azimuth angle output of the antenna follow the input angle of the potentiometer. Below is the explanation on how the system works to the function block. So from the angular angle, we're going to the potentiometer input, which is input. Then going to the motor, then going to the differential amplifier, then going to power amplifier and motor and load, and continue with the gear and angular angle. So after the gear, which is a loop to the power. Continue with the 2.1 mathematical modeling system. Transfer function model describe the relationship between the input and output of the system using a ratio of polynomial. The model order is equal to the order of the denominator polynomial. Then the root of the denominator polynomial are referred to as the model pools. then the physical system, which can be modeled mathematically with transfer function by the data given. Based on the figure 2.0 below, the function can be reduced as below. K to the which is power amplifier, K1 is divided by S plus A. Then continue to K1. S is time to S plus AM. Then it can be reduced as stated on the figure. So these are the formula for the reducer. T is equal to G times S divided by 1 plus G times S time H time S. So just compare the G, which is we can get K1 times K1 2 kg, and divided by S time S plus A divide then multiply by S time plus AM, and this is the formula we get. Then we just substitute it into the block diagram. Then this is the final equation. So that's all from me. Thank you.
Hi, Assalamualaikum and good day for our lecturer. My name is NAJMI bin SHUKOR. Today I will present for result. So for result, we design of open loop and closed loop antenna system, as well as the determination of pre-amplifier gain to gain K. Gain and K are all produced that aim to stabilize the system by meeting and gather the specific parameter. In addition, the open loop and closed loop design are different. So antenna system is a procedure that takes place a power amplifier, a motor and load, as well as gear all include. The only subload required for the building of an open loop antenna system does list below. This is because due to the fact that the design start with open loop. So from the research that we made, so before this, my friend already mentioned in methodology for formula to do a manual operation to get a TS 2 seconds. So from that we get this. You can see on the screen we get the value. So so from that, from the value from manual calculation, we input that at a block diagram at Simulink that I use Simulink from MATLAB. So at there we design the block diagram and input the value that we get from the manual calculation. So at the screen show the block diagram that we designed for open loop system, and the graph. This is the open loop system graph that we run, and then we get this graph. So next, after that, we design for closed loop system. So this is a closed loop system, and then we can see from that open loop system and closed loop system will change the graph different. Before that, the pattern of graph is different. So this is our get from the Simulink. Right. So I think Okay, good. All right. I think that's all for me. So, thank you.
Assalamualaikum and good day. My name is NURUL AMANINA DAYANA BINTI ARIFIN, FB19013. So today I'll be elaborating about the discussion and also the conclusion. So the discussion is the total system with the controller has been simulated after the construction of a state feedback controller for antenna azimuth position system. The response is acceptable and desirable because it has zero state error and a modest settling time and overshoot as shown in figure 13. Furthermore, the performance of the systems that respond using a PID controller is compared to the performance of the systems that responds using a state feedback controller. As a result, despite the fact that the PID controller has a short rise time and a quick reaction, the response is still rated poor due to excessive overshoot and a long settling time value. So as a conclusion, the antenna position control system greatly simplify and reduce the human work. They are used in many areas of daily life. First, we had to read about the system and conceptually figure out how it was working. We also use Simulink to verify this result. Pictures made in MATLAB shows how the system responds to step and RAM signal after each subsystem. After a completed analysis, the system is completed and the basic concept was understood. All possible solutions are presented above using mathematical equations and simulations in MATLAB. This research reveals how important the shared controller is in improving the antenna system overall stability. Furthermore, this research compares and analyzes the various tuning controller techniques now in use. User will be able to interpret extra information and tuning controller requirements more easily with the help of this comparison. Furthermore, many systems are currently in the process of shifting from analog to digital state as a result of the numerous advantages that digital systems provide. This emphasizes the importance of the work being done to digitalize antenna systems, as well as the fact that the ultimate goal of this study is to model and simulate digitally driven antenna systems. That's all from me. Thank you.